For the first 5 minutes, please welcome Philip to the stage. And I'm going to try and get the loud mic, okay?
Hi there, thanks. So my name is Philip Knight. I'm going to be doing a quick talk on why would a journalist want to learn Python. The way I was planning on doing that is talking about an example of mine. I'm a journalist. Why did I want to learn a bit of Python? So this is me. I'm now a freelance reporter. Up until January, I was a journalist on an education trade magazine. That's kind of where I got my use case for that I'm going to be talking about. Basically, it was something that a problem I had. I needed some data, and I just couldn't find a way to get good, up-to-date data. So I thought, right, I'm going to do it myself. My use case. Quite a lot of you probably know what free schools are. They're a new type of school that the government brought in 2010. The idea was introduced. We now have 254 of them, and the government has said that by the end of this parliament they're going to introduce another 500. So small but growing part of the school system. And one of the things, as a journalist, this is obviously a new, interesting thing. Want to know how they're doing, but most of them have started with only 1 year's worth of kids, so it's going to be several years until we get any exam data out of them. So, question: how do you know how they're performing? So the best thing we really have is Ofsted inspections. Ofsted goes in within the first couple of years of a school opening and gives it 1 of 4 ratings. 1 being outstanding, down to 4 inadequate. If you're a 4, bad things start happening to you. So my issue was I wanted to find out how all of these free schools, these open free schools, were performing, and there's no way of really, from the Ofsted website, getting data that's up to date on a group of schools, such as free schools that are open. So I wrote a bit of a Python scraper. This is the Ofsted website. For every school has its own, once it's been inspected, gets its own page. This is the rating here, inspection date, publication date of the inspection report. The actual reports I haven't tried to scrape because scraping PDFs is way beyond me at the minute. And this is what I built. So this is the site. Basically, it's a scraper, hits the Ofsted website every morning, 6 a.m. For every free school, grabs the results and then visualises it. So there's a bit of a breakdown. There's different types of school, and then a big table with all the results. You can filter, so you can check the sorts, check the latest results, that kind of thing. So this gives us information that would otherwise be really hard to get. We can see that about 75% of schools are outstanding or good, and you've just got 3 that are in this sort of danger category. How did I do it? That, if anyone wants it, is a URL link. Backend is Python 2.7. So it's written on something called ScraperWiki that I don't know how many of you have come across. It's a code in your browser tool. So if you're, you might not actually need to use it, but it has some advantages as far as I'm concerned. It is paid for, but it's free for journalists, which is quite nice. You can schedule it, so you can run your scraper, say, once a day, 6 a.m. One of the real big plus points for me is that you can easily get a JSON API endpoint for whatever data you've grabbed, which is basically what I then use to produce my front end. Libraries, really nothing fancy. Requests. Beautiful Soup is a very common, I think the most commonly used scraping library. And then ScraperWiki itself is also a library that basically helps you save a SQLite database of your data. Front end, I've seen a couple of talks today that have mentioned D3, JavaScript library. That, if you're getting going with it, is a very good book that takes you from sort of first principles to being able to do some basic pie charts, that kind of thing. If you're interested, please check out the project. My code is all up on GitHub under an MIT license. And I'd be interested to hear any feedback, any thoughts anyone had, either in person, Twitter, whatever. I'll make that 5 minutes. We time?
Time's up.
Cool.
So yeah, you might have seen my talk on hacking human language, and this is about detecting stories in books, because I do work on books and book summaries. So yeah, story detection using LDA.
5 minutes.
And I'm just basically building a tool to discover stories in text. And first and foremost, it's very hard to define what constitutes a story and how a story can be detected. So as a working definition, I just use stories as narratives on certain themes like friendship or habit, and we can discuss if this is an oversimplification. It surely is, but it was useful for this. So the solution I came up with was identifying stories by comparing text chunks from a story to topic word clusters. Unfortunately, I didn't have to do that myself. There's a really cool publication by Jokkes and Minno where they used latent Dirichlet allocation, LDA, to identify and extract hundreds of topics from a corpus of 3,346 works of 19th century British, Irish, and American fiction. So this is LDA, and I probably won't have enough time to go really into detail. But the nice thing, again, we live in a Python world, so we can just use this LDA model in GenSim. And what it does, basically, it comes up with these topics. So you have all these clusters of words which are similar to each other from the documents, so from these 3,000 entire books. And then actually the researchers, Jokkes and Minno, they went through it and labeled it, because that's very tedious. So I had 500 labeled clusters of themes from books. So how did I detect the stories? I took my text, I subdivided it into chunks of 30 sentences, and then for each word in a text chunk, then the module was looping through the available topics and looked at words associated with that topic. So this is what came out when I put in the book The Power of Habit. And as you can see, you have amusement while visiting places, which is rather obscure, but you also have things like friendship, society, pleasure. And so I did this for chunks, always 30 sentences each. And you actually have habits somewhere, I don't see it right now. But you also, habits and customs, you have duties, task, employment. And that was all I wanted to show you. Thanks.
Hello everybody, my name is Maria and I study mathematics at the University of Warwick. And I would like to start with this quote just because I like it and I think it's quite suitable. A theory has only the alternative of being right or wrong. A model has a third opportunity. It might be right, but irrelevant. Yeah. So what are the reasons when it goes wrong? There is a very nice story. It's a literature. And it's about a king who wanted to make a map of his kingdom. And he was keeping asking his data scientist to make it bigger and bigger. And then at some point, the map just became as big as the kingdom it represents. And of course, there was no purpose of such a map. And when I discuss the story with different people in mathematics, there is two types. First one say like, okay, but the king is right. We want more details, we want more data, we want to be as exact as possible. But the truth here is that we have limited resources, we have limited memory. And the truth is that this king, he didn't want anything. He didn't got a map he needed to just because he was so strict about what he wanted. So sometimes it's really better try from something simple. I'm not saying that the complicated models are bad. No, they're amazing. But it's always good to try from something as simple as possible. And this is my personal experience. This is part of the master thesis I've done. And originally, I started to do something really amazing, really complicated, something nobody ever done before. But it didn't work. In 2 months, I had nothing. And then at some point, I just made this plot. It took me like 15 lines of Python code. And it told me more than 2 months I've done before. Yeah, so again, I really like when there is complicated models, but sometimes it's just better to start from simple plots. Yeah, so this is how you might find me. I'm graduating soon, so I'm open for opportunities. Yeah. It's not all. Yeah, one more minute. Yeah, I love Python. I have an art degree, and yeah, that's all. Thank you all of us for inviting me here. I wish you all the best with your research and with your job, and I hope to see you in Py meetups.
Hi, I'm Gemma, and I'm a developer. And it's been 1 hour, 47 minutes, and 13 seconds since I touched a line of code. I spent 7 months working on a hair care website. And of those 140 or so days, I enjoyed, give or take, about 3 of them. And those days were the days I got to optimize things, optimize my code. And I'm here to talk about why I love doing that and why you should care about it. Admittedly, I feel like you probably don't need to be told this, but occasionally it does need to be said. I usually work for agencies on short timescales where getting something to work is all that matters. There isn't necessarily, there's no business requirement in getting it to work even faster, even more efficiently. But programming isn't just a job for me. I enjoy it, I love it, but it is fundamentally, it's a craft to me. There's an element of problem solving, all these challenges I enjoy, but fundamentally, when I want to build something that's efficient, that's beautiful and well engineered. The part of my brain that writes code is the same bit of my brain that writes prose. There's a flow, there's a rhythm, there's a weave and a weft to it. When I take something that works slowly and make it lightning fast, it's not only an enjoyable challenge, it's the pinnacle of my skill. I don't feel like I'm a code monkey mashing buttons anymore. I feel like I'm actually an engineer at that point. It's something I love doing. When I was writing this talk, I came up with a few ideas with some problems I was working on, and I had to close my editor and say, write talk first, optimize later. Unless you're living right on the event horizon of a black hole, time's kind of important to you. And even then, still very slowed down time. But it doesn't matter whether you're caring about the response time on a website or whether you're doing deep learning. Time is directly proportionate to your AWS bill. So I'd like to introduce you to my latest obsession, rescuing Bill Kerman. I don't know if any of you have got lost on Kerbal Space Program. This is my Minecraft. Back during my original experimentations, I left poor Bill up. Actually, if you look at the orbit, he's really close to home, but he's never getting home because I kind of ran out of fuel. So I decided my space program was going to devote itself to rescuing him. My first attempt was look at the original craft, build in all the redundancies, add lots of extra power, consider all the possibilities, and I got something that worked. There's one slight problem here. If anybody understands orbital mechanics, you'll understand that when I launched this thing and it left the Earth-Moon system without using any orbital engineering, or any orbital redirecting, I may have made it a little bit too powerful. So I went back to what am I originally trying to do? The problem is, when I was designing the original craft, it needed a little backup engine that could decelerate out of orbit. So I started working on a basic probe, automated systems, very lightweight, and all it was going to do is go up and put an extra fuel tank and a little rocket on the front end. If you look at sort of the scale, this is what actually brought Bill home. So what I'd like to now talk you through is my 3 top tips for optimizing your code. First one, don't optimize your code. This is something I keep coming across, and it's something occasionally I still do myself, is I come across people who are stuck trying to solve problems and optimize all in the first step. What matters is, with your first iteration of your code should be that it works. Doesn't matter how fast it is, doesn't matter how elegant it is, get it to work first and then optimize it. Now, as you get better, you'll naturally make things more as you get better, you will naturally make things more optimized. What I write in the first draft now is far more optimized than what my final product 5-10 years ago. Second step, be evil. Always stress test what you're doing. So build. Build a large data set, throw it at it. Sorry. Last thing is, okay, so build a large data set, throw it at it. Even if it's larger than what you're expecting at the moment, it will show you where you need to focus on. Final thing, break things down to as individual components as possible, and then you'll be able to focus on the right areas, which obviously goes back to profiling. But anyway, this is me. I've been programming for too long, and thank you.
Yes, so start the timer, there we go. So while I was listening to all these different amazing talks we're having here in London, well, one thing kind of reminded me of my actual education in social science. So I have one confession to make. I'm not really a data scientist by profession. I'm actually trained as a social scientist, an anthropologist. And as an anthropologist, I like to ask things about culture and about all these kind of aspects and language. So from that perspective, let me just show you some of the things which in anthropology are considered really important and mostly through crises which have occurred. I wanted to actually share my ideas about these things, how they might also apply to data science. Well, switching over to, from social science more to fundamental real science, as we might call it, I was actually amazed by the lack of philosophy and the lack of ethics and the lack of kind of moral argumentations about what we are actually doing as data scientists in society. So therefore I would like to just tell a little bit about ethics. So ethics is the branch of philosophy that deals with the distinctions between right and wrong and with the moral consciousness of human action. And basically, if that's what we accept as a fact, we can also say that data ethics would be the moral responsibility influencing any of our activities and practices as data scientists. So, what does that mean? We all know the Hippocratic Oath for medical science. It's not really legally binding in any sense anymore, but it used to be. I think you could be killed or shot or whatever if you would break it as a medical specialist in ancient Rome. I will prescribe regimen for the good of my patients according to my ability and judgment and never do no harm to anyone. And of course you can't really compare medical science to data science. It's very different things from what you're doing for clients or on the web, from helping treatments or where you might be able to kill people. But at the same time, and especially my discipline is deep learning, where we all know we're all afraid of Skynet and maybe things taking over our jobs and things like this. I think it's really important to question these things and think about what might be actually the consequences of our actions, which we're doing. And as an anthropologist, I was always slapped around by my professors with the AAA Code of Conduct, so the American Association Code of Conduct, which basically, in short, just says, do no evil, Google style. But how this came to be is actually quite interesting. There was no such code of conduct until there was this big, a big crisis story. Darkness in El Dorado is one of the books which describes it quite well, which was about an anthropologist team who were studying an Asian tribal folk called the Yanomamo. And they kind of misbehaved there. They overrepresented certain things. They had some sexual intercourse, was maybe not really considered nice. They didn't really inform the Yanomama people about what they were doing there, or there was no code of conduct or ethical concerns about these things. And there's all these kind of other stories about that they might have also committed some unattended genocide by introducing some different kinds of vaccines, which then turned out not to be actually really true, but it anyway sparked a debate, and that's how the AA Code of Conduct was born. So for data science, we also have seen some of these things happening in smaller extent. We have Facebook facing criticism for its study, where they basically changed for half of their study group, they changed the timeline to showing only a little bit more positive news, and the other half showing a little bit more negative news. But of course, people were not informed of this, that they were part of an experiment, and rightly so, I would say. They were very much criticized for that. But there's other things also happening with data and with the systems we built that, of course, subscribe to some of this, which is more about privacy and things as this, Prism, yes, we scan, etc. So having all of these things in mind, I think we do have some ethical concerns, and we should really be able to think about these things. So the question then is, do we need a Hippocratic oath for data science? Which basically means, how do we explain to society what we are doing as data scientists or computer scientists, however you want to subscribe yourself, or data miners? Algorithms don't speak. Algorithms also have to be explained by itself, that there's an algorithm that it can't do right or wrong. It still means, is that where our concerns end? Should we take it further than that? And also, who owns which data? If there is a data set, does that mean that it's available, that you can always use it? Or do people have to say something about it from who is in the data set? That's all I wanted to say. And something I did forget to mention for my talk on deep learning, if you ever find yourself in the windy Stockholm, come around for the Stockholm Deep Learning Meetup. And that's it.
Right, so yesterday Russel was giving a talk around basically looking at why Python isn't ideal for doing number crunching stuff, really kind of intense computational stuff. And it made me, the result of the talk made me feel a little bit angry, really, and I couldn't quite figure out why I felt angry about it, or kind of frustrated by the message. What he was doing was he was trying to calculate pi using an algorithm, and he kind of showed that Python isn't fast enough to do this, and you need to look at other languages like C++ and D. So I really wanted to prove him wrong, because I really like Python as a language. But I wasn't quite sure why he was wrong, right? So this talk is basically about me kind of investigating why I feel he was wrong. Okay, so I can scroll. So one of the first things I did, right, was I decided I'll write a C extension to implement the code that Russell was using in his benchmarks, because they're nice and simple, or, so I was thinking. So this is the kind of code you need to write here in this block here. This is the kind of code you need to write to implement a C extension. This is Russell's algorithm. It does some stuff like it releases the GIL, so that you should be able to run it multi-threaded. I've broken his algorithm down so you can run multiple bits of it in separate threads. The idea that would be that you then wrap this in some Python code that would spawn multiple threads and split his algorithm over multiple threads, right? This is just the boilerplate for registering a module. After actually doing this and finding out, so initially I was thinking this is really simple, it'll be easy to prove Russell wrong. It turns out actually it was much more difficult to write a C module than I remembered. I spent a lot of time looking at the docs, I spent a lot of time debugging it. I broke things in really bizarre ways that I wasn't expecting just by deleting lines and bizarre things happening. It's still much faster than implementing the same algorithm in Python, but it's just not excitingly fast, right? It's still quite boring, right? It takes 2 seconds to calculate pi, right? And I want pi much faster than that. So the next kind of bit of thought I had was, kind of my little Chromebook here, which is what I was running it on, only has 2 cores, and they're quite weak cores, right? So this is a CPU-bound algorithm, so what I need is more CPUs, right? So I'll just go to the cloud and I'll get loads of CPUs. But an IPython notebook would make that really simple, because it has built-in distributed computing support. It could be quite easy, but there's also quite a lot of negatives with that kind of thing. It's a lot more costly. It would require some kind of cluster management code, and even then I'd still have at least network latency as a problem. So it'd still take me maybe 100 milliseconds or so to get a value for pi, which just seems too long. So that then led me to think, well, maybe someone's figured out a better way of calculating pi. Surely someone's calculated pi before, right? So the result of that was me finding very quickly some code on Stack Overflow that purported to calculate pi, and so I turned that into This is basically the code I found on Stack Overflow. I turned it into an infinite generator for digits of pi. So this thing will just yield, 3, 1, whatever the other digits of pi are. And there we go. So here it's using some iter stuff. So I'm generating 2,000 characters from pi as a string. And then to make it kind of something nice that I might actually want to use in Python, I'm using the decimal module. It's built into Python, and I'm creating a way by which you can get a decimal, which is like it's a high precision, like a kind of fixed point representation of numbers. So I'm creating a way to construct that, and I use like the decimals context and stuff to decide the precision, or you can tell it how many digits you want, that kind of thing. So the result of that is that we can generate pi to a load of different numbers of significant figures, and it's fairly fast. So Russel's example took well over 2 seconds for Python implementation. This one takes half a millisecond to generate 29 significant figures, and a few milliseconds to generate 200. So what did I really conclude from this, right? Because this is a pretty silly, weird thing to be doing, right? The micro benchmark, which was obviously a kind of silly, contrived example, what was it that I felt was wrong with it, right? I didn't feel like this is ever a kind of problem I'd come across. Okay, right. Okay.
Conclude.
So conclusions, right. So I don't think that this is really a problem with Python. Python makes it really easy for you to write good algorithms and distribute them. So I don't really feel that we have that kind of problem because it's really easy to distribute better algorithms. So basically, better algorithms is my conclusion.
Okay, so this is going to be a very quick talk about going to Mars with Python in 5 minutes. Okay, so Warren, this is a rocket science talk, okay? This is gonna be, well, interesting with lots of rockets and photos of spacecraft and everything. So what is astrodynamics in the first place? Astrodynamics or orbital mechanics is a branch of mechanics which studies practical problems concerning the motion of rockets and spacecraft through space. For example, this is the plot of the Rosetta Journey mission, which is the mission that we used to put a probe on a comet for the first time in human history. And you can see there that the trajectory was quite involved because it had to go through Venus and then Earth again, and in general doing a trip that was like 10 years long. So what is Polyastro? The pure Python library for astrodynamics, which is my personal project, what I'm going to talk about right now. I also love Kerbal Space Program, by the way. So let's go to Mars. These are some initial imports that I had to make. These ones are the Polyastro modules. The last one is we are downloading a file from the NASA, the JPL website, which will tell us the position and the velocities of the planets. So first thing we have to do is defining the orbit. We basically need 3 things: the attractor, in this case the Earth, the position, and the velocity vectors. And we do this code, and we have a nice plot of the orbit. Second, we have to locate the planets. Using the NASA file that I told you before, we can provide a date in time, and then we retrieve the position vector and the velocity vector. Okay, there's a bug over there that I still have to fix, but it kind of works so far. The third thing, we have to compute the trajectory. So there's an algorithm called the Lambert problem that I implemented. So basically, we give the initial time, the arrival time, and it calculates the 2 velocities that I need to develop to go from one side to the other. By the way, this is implemented in pure Python. As you can see there, that line was the previous implementation in Fortran in blue, the pure Python implementation in red, and the Numba implementation, in blue and the Fortran in green. So when I saw this, I said, okay, just throw away all the Fortran code and get on with it. So fourth, let's go to Mars. This is a lot of boilerplate code to get all the parameters working and all the plotting stuff. So nothing interesting. And there you have it. We went to Mars. This is actually the plot of the Mars Scientific Laboratory, which is the Curiosity rover. And well, there's still one thing that I can do, which is making it interactive. If you went to my talk before about IPython Notebook, you already know that I am in love with it. But oh no, I have to begin from the start. Okay, don't worry, no panic. Oh man. Do we have time still? Yes, please. Run all? Yes.
It's quick, right?
Well, come on, come on, come on, come on. Don't make us wait that much, please. Where is it? Okay, live demos sometimes work. All right. So they are having again. Come on, quick. Go to Mars interactively. Okay, so I have two parameters, the date of launch and the time of flight. So if I change in advance the time of launch, there you will see that the Earth is moving forward in time, okay, in its orbit. And if I also change the time that I want the spacecraft to travel, for example, this way, then I get a shorter or a longer orbit in this way. Okay, so that's pretty much all about it. I finally made it, and thank you very much.
Ready?
Yep.
Go.
Okay, hi, I'm David McGiver. I'm here to talk to you about my testing library, Hypothesis, which actually has nothing to do with hypothesis testing. I'm really sorry about the name. So what is it actually about? It's a randomized testing library, and what it does is that instead of in your tests writing examples yourself, you say roughly what shape of examples you want to try your code against. And it then generates a whole bunch of examples of that shape. And if any of them fail your test, then your test is failing, and it gives you a nice little example to demonstrate the problem. We are going to look at it on a problem that you've probably not encountered before. I only use it because it's one I'm quite familiar with. It's called feedback arc-set for tournaments, and it is a ranking problem. You have a matrix that says, of these coordinates, which order should they go in? And if everything were nice and transitive, this would just be a simple sort, but it's not. And actually, this is a super NP-hard problem. It's basically for people who found traveling salesmen too easy and want something a bit more of a challenge. So n equals 30 you can do, n equals 100 you can't unless you're really lucky. Here is a really bad implementation. The top is our cost function, and the bottom is the heuristic sorting algorithm we're going to be using. And what we've done here is we've given every index a numeric weight, where a higher weight means there are a bunch of other numbers we've been told need to sort before this. And so a higher weight should indicate that this should go towards the end. And we just add up the numbers and we hope to give the right answer. So this is bad. You should never use this implementation, but it might be a good heuristic starting point. And let's use hypothesis to show us that it's bad. And this is what the tests look like. This is all. And what we're doing here is we're saying, okay, this is supposed to be a global optimum. So at the very least, it must be a local optimum. And in order to be a local optimum under any sort of transformations, the one we're going to go with is we should never get it backwards. We should never find ourselves in a position where if we just reverse the order the optimizer gave us, we actually get a better result. That's probably a bad sign. So we say to hypothesis, can you give me 3x3 arrays of unsigned integers, which we're going to use as our weighting tournament for the scores. It could be much larger than 3x3. I picked 3x3 because I need the examples to fit on a slide. That's the only reason. And other than that, that's pretty much it. We have our test function. It runs against the tournament we're given, and we do the cost of both the forward and the reverse result. So we run this under PyTest. It can run under anything, but I like PyTest. And it says, nope, your code is broken. And this is the example that Hypothesis has given us. It's this lovely little matrix of zeros and ones. Honesty compels me to admit it's usually not that nice. We got slightly lucky here, but it's usually quite nice because Hypothesis has good quality simplification of examples as well as random generation. And what has happened here is if you see all the columns add up to 1, and what that means is that we've got the same heuristic weight for everything. And so the sort was basically useless, but actually there was something interesting going on in this matrix, and we wanted to put 2 before 0, so the reverse was better in this case. And the printing is mostly PyTest output. And that's pretty much it for using Hypothesis. You can use this. We benefited from the fact that our implementation was really bad, so it was very easy to write a test for this, but you can use much the same technique for much better implementations. You can perturb the output and assert that this doesn't improve the result. You can start from another point, and you can run a local optimization procedure. You can do anything like this for testing an optimizer. And you can use it for other things as well, but this was just a good example for using the NumPy support. And that is more or less all I have to say on the subject, so let's have a quick conclusion. So hypothesis is hooking up your examples to high-quality random data, so you don't have to write examples yourself. You can focus on testing the invariance of your code, which is the interesting bit and the important bit, and you don't have to spend a lot of time on other parts of the process, and it will probably do a better job than you would have anyway. Most people find that Hypothesis finds interesting bugs in their code the first time they run it. So basically, you should be using Hypothesis to test your code because it is great and it will save you time and it will improve the quality of your software. And that's pretty much all. That's all I have to say. Here are some links. The top is me, David McGiver. The middle is the Hypothesis documentation. And finally, here's a link to these slides if you want to take a look at the examples. Again, I'll also tweet these on the hashtag. That's all I've got to say. Thank you very much.
Okay, hi. Name's Carole from Plotly, Canadian-based company from Montreal. Startup, just been going now just over, 18 months. What I'm going to be to do today, quick overview of Plotly, very quick, followed by using IPython notebook widgets. Okay, one of the things I wanted to get over is this, the last couple of days and other seminars, I've been meeting lots and lots of people. They've all got this idea, Plotly runs on an S3 cloud, and you've got limited files, and my data should be kept very, very secure within my company. We do have an enterprise edition, which runs on a secure Linux server on your company premises. Something like quad-core i5 or i7 will run it. So it does stay behind your firewall. So please don't think of us as online only. We do run on your servers as well. Okay, so what do? We've got APIs, Python, MATLAB, R, Node.js, Julia, and Excel for inputting data. We do look at figure converters, matplotlib, ggplot, etc. Why bother, I hear you ask? The reason is because we convert your figures into beautiful online shareable Plotly graphs, which are ready for publishing, whether that's online or on paper format. Right, how do we go about it? For example, I've got some code here. It's within a Spider, it's Anaconda Python interpreter. You run the code, it automatically pulls up Plotly, and it opens up automatically showing the plot. If we go through from here, we can see we also get the data. We also get the code, but if you look at the right-hand side, we can also communicate with people that are programming with MATLAB, JavaScript, R, and Julia. We can also keep all the original data together, which means it never gets lost, and we also have version control as well. What else can we do? We can fork and edit, we can share, we can edit traces, we can have multiple axes, we can add labels, we can drill down, we're using D3, so we can drill in and out of the graph. We can also collaborate and embed graphs as well. If you look here, we can add a collaborator. It's a bit like Google for graphs rather than doing it online. And we can also, if you see on the right-hand side in the middle, we've got embed. So we can go straight from Plotly and embed into a website. Other things we do, you can collect data. Arduino is one example where we can get streaming data. So if you are measuring things like temperature or other basic sensors, we can cope with that. Okay, so the next thing I'm going to do, I'm going to end this, and I'm going to go and show you where our widgets are. Okay, so this is using IPython notebook, which has got the widget functionality. With this, we're running it with a Plotly 3D graph. Why bother? The reason being is that you can drill in and you can drill out of your data. You can look at certain parts of it which might be of interest. This one's a 3D one. I shall show you another one. This is using pandas here. and you might say, well, what can we use there? But it's running here. You can see it's actually sorting. I just want to have a look at a taxis now. Maybe the next one's going to be a tree. We're having a look at trees within the chart. So you can see again, now we're looking at taxis again. So you can choose what areas of the graph you want to look at. This again, IPython notebook using pandas. And my very last one I'm going to show you is this, because very soon we have maps coming from Plotly, but you can see here, we can go over the topography of the map and we can actually see the proper contour. So again, that's utilising widgets using IPython notebook with Plotly. So thank you very much indeed for listening to me.